I hit the publish button on video 35, and I'll link to that up there in the corner, as I realized there are problems here. I haven't even put power to it yet to try to test it on my own. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. And so I just wanted to go through these. One of them I realized before I actually, or while I was editing the video, is that I never actually hooked up these 8 address lines down here. They should be hooked up over here to the 8 bits that are appropriate coming in before this latch IC. And the reason you want to do it before is you want to have the EEPROM have the ability to settle its output before things start changing on it. Problem number 2 is I had every intention of latching the output with another 74 HCT 574 so that the EEPROM was then free to turn around and resolve its output for the next instruction that was being prepared over here. And then the third problem is I had every intention, I missed it when I did the instruction register, and I missed it again when I added the control logic, but I had every intention of adding decoupling capacitors to each one of these ICs, and I totally neglected to do that. I neglected to do it here on this breadboard, and I neglected to do it here when I added the control logic. So this video is kind of a redo. I want to go back and redo some of this stuff. Some of the effort that I put into here is going to have to be backed out and redone. Basically, this is a do-over for me so that I can get this working properly, because it's not going to work properly the way it sits right now. First thing to do was to actually remove everything, or just about everything that I did, and take it back to a place where I can actually work with it again. So let me get started on that. So yeah, pretty much everything that I worked on. So I still have the clock here, and I've got the natural clock output here still, and I've got the inverted clock output over here still, and I'll continue to use those. I want to take the 74 HCT 574, drop it in here, and I'm going to immediately add power and ground. At the same time, I'm going to go ahead and, before I forget again, I'm going to get these decoupling caps set up here for the instruction register. Okay, the last one here is going to be here, but I believe what I want to do, and let me grab it. Because I'm going to have to remove this EEPROM somewhat frequently, I'm going to use a disc style capacitor. It's the same size, 0.1 microfarad. But I'm going to go from here to here instead of the traditional across the pins. Perhaps if I get brave, I might try to solder to the top of the pins so that when I go to program it, it's still available. It's still able to actually get into the programmer. We'll see how that works. I'm not totally convinced I need to take that chance yet, or that I'm ready to take that chance yet. So now I have 8 output pins. I have 8 address pins. Let's start with the 8 address pins. Let me bring up the format of the instruction word and how that is going to relate to the lookup on the EEPROM. It's the center 8 bits of the 16-bit instruction, which turn into the lower 8 bits of the lookup into the control EEPROM. So this would be 7, 6, 5, 4. I'm going to run out of that color. So let me switch over to yellow, just so I've got something that distinguishes. 3, 2, 1, and address 0. Now let me Just double check against the pin diagram. Yeah, 7 down to 0. 3, 2, 1, and 0 are coming from the most significant nibble. So bit 7, bit 6, bit 5, and bit 4 of this instruction word coming in. The most significant nibble of these of the address lookup, I can't really say that because the reality is these are just the next 4 bits. So these are bits 4 through 7 come from the least significant nibble of what is going to be latched here. Okay, I'm just checking my work and make sure I've got that right. Those can be wired up, and then I'll reclaim my temporary hookup lines here. So let me get these taken care of and get those wired up. While I am opposed to taking down the video, created all of these problems, I'm not opposed to updating the thumbnail, calling out the fact that it's all wrong and I end up redoing it. If you think that I shouldn't do that for any reason, let me know in the comments. Otherwise, I'm probably going to update the thumbnail while I am traveling so that it's more reflective of reality. The clock is available here because it's used. Same clock is going to be used to latch this as is going to be used to latch here. And so I should be able to pull that clock over, and I might even be able to use, well, I probably want to go around for this. Once again, to refresh my memory as well as hopefully yours, as I try to push that down. It didn't work out well. I have the actual clock coming off the clock module entering here. This 74 HCT 574 and this one are tied together, and that line is down here. You can maybe just make out a yellow line there. So those are tied together, and then this one is tied to the same signal. So on the actual clock from the clock module, which is ahead of this delayed clock for everything else, is when the control module is going to latch everything. And I believe I need that delay, but it also gives me the ability to drive absolutely everything else in the computer from the clock and the inverted clock over here. Now, I have bit 0, 1, and 2. Let me not use my finger. Bit 0, 1, and 2 of the output word, plus 3, 4, 5, 6, and 7, which all need to come down over here. So bit 0, 1, 2, 3, 4, 5, 6, 7 all the way across. And I believe I need an output enable here as well. Let's deal with that. I should probably be smart and pull up that pin diagram as well. Yep. Clock is up here. My control signal's clock up here. Output enable down here. And then my 8 pins straight across. So using green, 0 goes to 0. 1 goes to 1. And 2 goes to 2. Now moving to the other side of the EEPROM. 3 goes to 3. 4 to 4. 5 to 5. 6 to 6, and bit 7 to bit 7. So that will give me the ability to latch. And so now the challenge is getting this wired up in such a way that I can still remove and program the EEPROM here. I think I'm going to have to change the size of this. Okay, that pulls that back a little bit away from the IC. Outside to outside, and then work my way in towards the middle. I believe I can bring over and then bring down this way and then over the IC. At least that's going to be my plan. Okay, that should allow me to get the IC out here, the EEPROM. This doesn't look quite as neat as it should, but I think we'll still be okay. Now my challenge is the outputs off of this are here, and this is what I now need to drag out everywhere. Now I need to identify exactly how I want to set up these. Can I fit them all in here? They'll fit. Do I want them to fit? I don't believe I want them to fit. So once again, this would be the address bus assert. This is going to be the AND latch signal. And then this is going to be the increment, which gets pulled together here. Power, and I am leaving, I'm going to grab a longer one here. I'm leaving a little bit of space in the breadboard up here so that I can hook power and to chain another board in up here. And then this one down here. Ooh, that's going to be tight. How do I want to do that? I don't believe I want to do that. No, I think I want to go up here with this. Now what that should allow me to do, I'm hoping, is maybe give a landing spot for each of the modules here so that I can connect it. Let's see how that works out. Okay, now I'm bringing up the control signals because I need to refresh my memory how each of these were going to be. All right, so the bus assert is just an inverse of the actual signal coming off the control. Okay, so for the asserts, I use the low 3 bits here. So these will be these 3 bits, pointing implement. Those will be these 3 bits over here, which need to come over to this. The next 3 bits will need to come over to this, and the next 2 bits will need to come over to this. That's the way I had it wired up originally. I don't like that anymore because that means everything has to cross. So I'm going to take the most significant 3 bits and bring them over here to this 138. And then that's going to change, of course, my definition of how this would have been programmed, this control would have been programmed. But I'm okay with that. For the 38, I have A. So this is going to be bit 5 is going to go into pin A. And then B, which is going to be pin 6, will go into pin B here. And you'll see that I'm reversing the order of these. I also need the next 2 get pulled down such that we're always outputting. There is a G, which is active low. That's G2A. G2B is also active low. And then G2C, which is active high. I'm sorry, G1, which is active high, is that pin right there. Now, that said, I want 0 to be my control signal for the program counter, and that has to go through a buffer. So that's going to be into this signal right there, which I still have my buffers hooked up, and then the output of this is my program counter assert. Let me get that to be a little bit more permanent. That then finishes up my assert. The next 3 lines, we're going to go into this. So again, this is A, which is farther down towards the least significant bit, and then B, which is up here next, and then C, which is up the highest bit that has not been used. Now, I said this before, this is the end latch. I said this before that the end latch is going to be controlled by the clock. And the way that I want the signal to work is I want it to go low, signal NAND the inverted clock, meaning that signal is high. What I believe I did before, and I'm questioning it now, is that I actually took the real clock and hooked the real clock up to the active high signal. Let's grab a little longer wire here. No, I hooked it up to the 2N and active low signal. I'm going to have to put a scope on this to make sure that it's working right. So this is the active high. And here's the other active low. What am I doing? Wire up the right IC, Adam. Y'all are probably screaming at the screen. And you should be. And then this is the active low. I'm going to move this over to that active low. Now again, output 0 needs to come over here to a buffer. Again, I'm using an XOR here for the buffer, and this is its output. Now, I do have less confidence in this, so I am going to have to break the scope out when we get this hooked back up into the build. But in the meantime, I can put that there and make that connection permanent. Now, before I go any further, I'm going to go ahead and make sure I've got these decoupling caps installed. All right, the last two bits here need to be brought up here and ANDed with the inverted clock. So the inverted clock is here, and so that's going to put one input there and then a second input here. The outputs are going to be here and here. And so then the other inputs are here, which is bit 1. And I like this now because this lines things up better with the most significant bit on the left and the least significant bit on the right. So let me clean this up a little bit, pull the unused bits out the way. Okay, so once again, my input is here. This is for the clock. I am now latching the output of this EEPROM with the actual clock module. This is my assert onto address bus 1. This is my and latch signal. This is bit 1 of the program counter's load increment decrement signal. This is bit 0 of that same signal. So the combination of those two then get demultiplexed actually on the program counter register itself. And so those signals should be relatively accurate at that point. I've got the decoupling in now, which I did not have before. And once again, I'm not putting LEDs on these because the actual control signals on the, this is the old one, on the register module itself actually show exactly what's going to happen. My intent is to be able to check the lines that the signals are working right here, and then from there debug everything from here, knowing that this is all working correctly. Now I'm not going to apply power to this in this video. I am going to save that for when I return. This will probably be released while I am traveling, and so you'll see this. I'm trying to queue up a little bit of footage that I can actually get released while I'm away. I'll scroll my to-do list up at the top as well. While I'm traveling, I'll probably work on also getting the circuit first project updated with the changes that I've made recently, being the fetch register as well as the instruction register with its control signals.